Okay, guys, good morning, good morning. So today we are going into our brand new topic, okay, topic 13. We're going to go into a couple of things, okay? We're going to go into angles, right? How to distinguish an angle, what is an angle, okay? We're going to learn our main two angles, all right, which is our right angle and straight, okay? We're going to go into how to use a protractor. Oh, protractors, that's pretty cool. These are protractors. Yeah. So these here are your protractors, okay? And you're gonna notice that the protractors have rulers. We're gonna speak about that. You're gonna see that the protractor all has numbers in it, right? Okay, so measuring angles and using a protractor to measure the angles is what we're gonna go into today. And we are also probably going to touch, well, I don't know if we have time, but we're probably going to touch a little bit of area and perimeter, okay? Knowing the formula for an area, knowing the formula for a perimeter, okay? And then finding the area and perimeter for a rectangle. And that's going to be super, super easy. If you guys know your multiplications, your times tables, you're going to get this like nothing, okay? So, again, our objective today, hopefully by today, I can identify and classify different types of angles, okay? I can measure and draw angles using a protractor. And I can calculate the area and perimeter of a rectangle, okay? These are the main things that we're gonna work on topic 13, all right? We're gonna start working all the way through it, all right? And at the end of our main three lessons, we're going to take a topic test and we're going to see where you're at, if you got any, if you gained any knowledge, and if you gain any understanding of the angles, the use of a protractor, and finding out the area and perimeter of a rectangle. Okay, so first things first, I want to go into angles. Right, so we're going to go into angles, and angles are, at first, you're going to be like, okay, what do I need an angle for, right? But if you look all around this classroom right now, all around this classroom, there's all types of angles, okay? I'm going to give you examples of an angle. So let's look at this picture here, all right? We all eat pizza. Pizza is awesome. Pizza is amazing. I love pizza, right? If you look at the pizza, right, it starts off as a circle, right? Now that's the first angle I'm going to go into, a circle. Why? Because I want you to know first how a complete angle looks. Okay, a complete angle is a circle, and the degree, okay, the degree of a circle is 360 degrees. Now, Mr. J, do you mean 360 degrees in temperature, or no? 360 degrees. Degrees is the unit in which we measure an angle. Okay. We also use degrees in temperature, but in this case, right, we are looking at it with our math eyes, right? So we're using degrees as if we're measuring degrees in math, right? The degrees of the angle. So a 360 would be a circle, a full circle. So let's begin with that. A full circle is 360 degrees. 360 degrees. Now you see this little circle at the end of my 360? That is what we use to identify degree, okay? There are 360 degrees in a circle. Okay, now 1 degree is called a unit degree measure, right? So it's 1 out of 360. 2 degrees is 2 degrees out of 360. Okay, 360 will be our complete full circle degree. That's what we're going to start off with. It's like saying, for example, it's like having 100 pennies, which equals $1. Right? There's 100 pennies in $1. 2 pennies would be 2 pennies out of 100 in $1. 3 pennies would be 3 out of 100 in a dollar, right? So 100 is our main base number, right? Our full one whole number. So in degrees, 360 is our full number. It's our base number. It's our big number that we all want to get to, okay? So this is our 360 degree. This is our full circle degree. Now let's go into our second angle. Our second main angle, I would have to say, would be our right angle. This is called a right angle, okay? A right angle is very distinguishable because it has a square in its corner, right there, a square in its corner, okay? So when you look at a right angle has a square. Okay, now let's look at all over this classroom, including this example here. If you look at our clock hands here, our hour hand and minute hand, they are forming a complete square right here. Okay, if you look at our hour hand, so this is more like this. Okay, it's completing a square. So that is called a right angle. Now a right angle, this is called a right angle. Now a right angle has a degree of 90 degrees. That's the measure, 90 degrees. So whenever you see an angle that creates a full square right on the corner, that is 90 degrees, okay? Now, if you look again, all over this classroom, you're gonna find 90 degrees all over the place. The corner of the TV, the corner of the monitors, the corner of the tables, your corner of the books, corner of the, of what, Nathan?
The board.
The board. The corners of what you think it has a 90-degree angle, Adam?
I think it's this basket.
Okay, the corner of the basket is 90 degrees, okay? So you're gonna find 90 degrees all over this classroom. I think that's the most that you're gonna find. The tiles on the ceiling have 90-degree angles. So wherever you see a corner, creates a corner, it's a 90-degree angle. That's a right angle, okay? Now, the next and most important angle that I wanna go into is our straight angle. Okay, our straight angle, okay, is distinguished by a straight line. So wherever you see a straight line, wherever you see a straight line, you would assume that that would be a straight angle. So a straight angle is a straight line, okay? Now, the degree of a straight angle has, and you'll notice that it has another thing here, that's what's called, that you guys might not know. Should have gotten this in 3rd grade, but this point here, this is called a vertex. This is called a vertex. And you're gonna notice that all our angles are gonna have a vertex. Okay, the vertex, okay, the vertex is where two of the lines meet, two rays meet. A ray is a line that starts with a period or a point or a dot and continues on forever and ever. Doesn't matter where. If it goes to the right or to the left, it always starts with a point or a dot and continues on forever and ever. Go ahead. Okay, so that's the vertex. Now a straight angle has a degree, no matter what it is, no matter how you draw it out. If it's a straight line, it has a degree of 180 degrees. Now, Adam.
Yeah?
What do you see? Do you see a right angle inside a straight angle? Can you create a right angle inside a straight angle?
Yeah.
How would you do that? You can tell me. No, you can tell me.
So you could like the vertex. You could just write or draw lines just straight up.
Straight up, right? Good job. So if I draw a straight line down this vertex here, I'll have a 90-degree here and a 90-degree there. Okay? Yes, Jacob.
If the straight line is vertical, is it still considered like a straight line?
That is considered still a straight angle. Yes, as long as those two lines do not open up or close, it will still be considered a straight angle. Now, I want you guys to take a look at this. Okay? This is my circle, my 360-degree circle. I'm going to draw another one here. This is my 360-degree circle. Right? If I wanted to break this circle in half, okay? If I wanted to break this circle in half with a line, and if I told you that this line is considered 180 on this side and 180 on this side, do you see how a straight line can be half of 360? If you divide 360 into 2, you will have 180 and 180. Now check this out. If you divide that 180 into 2, right, into 2,
140.
what would be the angle for this here and this here?
90.
90 degrees. Good, James. So I'm gonna put 90 degrees here. Now, what would be the degree for this one here, Caleb?
Still 90.
What is it, James?
Still 90.
Still 90. 90 degrees. How about this one?
90 degrees.
90. How about this one?
Still 90.
90. You see how I just broke that 360 down into 4 equal parts, and each part will equal 90? But if I were to break the circle right in half, it'll only be 180, right? Because it creates a straight angle. Now, if I break it into 4, now you're creating 4 equal angles, right? Equal right angles, right?
Yeah.
So this is important for you to see because it's going to show you later on in the lessons and problems that I give you, you're going to have a questions like if you know, what would happen if, you know, let's say James breaks a 180 into 3 equal parts. 180 into 3 equal parts, and I ask you, what is one of those parts? What is the measure of one of those angles?
60.
It'll be 60. Good job. Because 60, 60, and 60 will be 180.
Mm-hmm.
That is your base. That is the number you want to get into. A complete number will be 180. But you're going to break that 180 into 3 equal parts, then each angle would be 60, 60, 60. Good job.
3 times.
Yes, 3 times. Okay. Let's go on let's continue on. We'll go into that even deeper later on. But it seems like you guys are getting it. Okay, so we have our right angle, our straight angle. Now, our next angle would be
Obtuse.
This is an acute angle. Acute angle. Now, an acute angle has a measurement less than 90. So it's less than 90 degrees. So it's an angle, right? It's a right angle. This is a right angle. And an acute angle is less than.
So like
less
85?
Than, okay? 80 for anything from 89 to 1 degree would be an acute angle. Yes.
So it could like so that an acute angle could be like you know, the comparing things like the alligator, which one chooses.
Oh, okay. So yes. So when you're comparing numbers, yes, when you're comparing numbers to see which one is greater, less than, or equal to, yes, the less than symbol or the greater than symbol, they do show acute angles. Yes. Let's go into our next angle. Our next angle would be obtuse. This is called obtuse angle.
Is it kind of like the opposite
obtuse.
of acute?
Now, there is two definitions of obtuse angle. Obtuse angle. This is acute angle. Put angle here. Okay? An obtuse angle is right at a 90 degree and is greater than 90, right? Greater than 90, but less than what?
180.
180. Less than a straight angle, right? So it's greater
than a right angle.
Greater than a right angle or 90 degrees.
But less than a straight angle.
Than 180. Okay, 180 or less than a straight angle.
Mr. J,
Mm-hmm.
are angles like gonna help you in life?
Yes, they are, and you're gonna see how in a second. Okay, so right now, this is the angle we're looking at. So normally you would see this straight line as a straight angle, but this angle seems to go beyond. It goes beyond the straight angle, so it's greater than a straight angle. This is called a reflex. This is called a reflex angle. Okay? A reflex angle. A reflex angle is greater than 180, but less than what?
360.
Less than 360. Less than 360 degrees. Real life examples, you're gonna look at, for example, look at this fan here. This fan here has two angles. Who could give me the two angles here? Do you see, what do you see there, Adam?
When I like tilt my head like this, I see an obtuse angle.
Beautiful. So this side would be obtuse. What would be this side though?
Reflex?
Reflex. Okay, reflex. Okay, so in what I want you to do now is go around the room, okay, and see what angles you see around the room and make a list of all those angles. So I need you to grab a crayon, okay, split the paper right in half, draw a line right in the middle of the paper, and then draw or write what you saw, what item you're choosing, and what angle that item has. Okay? So we're gonna go around and do it now. Good, Adam. Good. Very good. Very good. Let me see, Jake. Wow. Very nice. So you got straight angle, number line, right angle, corner of the board, the clock. Yeah, 360. Beautiful. The chair's leg, or the chair legs, obtuse angle. So now that we know our angles, all right, we're gonna go into the protractor.
What is the protractor?
So here we have a protractor. A protractor is a tool that we use to measure angles. In the protractor, you have a center period or a center. This is just like a vertex, okay? The vertex, right, this little center point here is gonna help you align your angle, okay? This line on the bottom here would be your baseline, okay? This is the line that you're gonna match with your angle that you have on your paper. So the baseline gets matched with this zero line here, this baseline, okay? So no matter where you go, let's say if you want to use the left side or right side of this protractor, okay, if you want to use the right side of the protractor, okay? And let's say I want to measure this angle here, okay? Let's say I want to measure this angle. So what you're gonna do is you're gonna line up your protractor to that vertex. Now, let's say I have my vertex here, this is my baseline, and this is my ray that's gonna determine what angle am I looking at. So what I'm gonna do is, I'm gonna put my, let me put this angle here. I'm gonna put my angle right there along my baseline, and my vertex, I'm gonna line it up. I'm gonna line it up with my vertex on my protractor, okay? So I'm gonna use this baseline to line it up with the baseline on my angle. I'm gonna use the vertex of my protractor and line it up with the vertex on my angle. You could have two angles. You could have an angle going this way as well. Okay, it doesn't really matter, but you could have two angles going to the left or to the right. But let's say we're using this black angle here, okay? And my baseline is pointing towards the right. Do you see where the 0, 10, 20, 30, 40, 50, 60 is at?
Yeah.
That's where I'm gonna start counting from, my right. Okay? You're not gonna look at the bigger numbers on the on the top. You're gonna look at the smaller numbers on the bottom, because that's where you're gonna start counting.
Since it's in a cube.
So my baseline, yes, my baseline is looking towards the right, right? Therefore, I'm gonna start counting from the right. 20, 30. This thing, man, this thing sucks. Okay. So my baseline is pointing towards the right. Pointing towards the right. So I'm gonna count from the right. I'm gonna start counting from the right. That 0 is my starting point. So 10, 20, 30, 40, 50, 60. I'm gonna get as close as I can to that ray without passing it. So now I'm at 50, right? So now these little lines, you see these little lines here on the protractor?
Yeah.
Those are your unit degrees, okay? Those are the 1 unit degrees. So you're gonna count by ones from that point. So you got the 50, you're at the 50 degrees, 51, 52, 53, 54, 55 degrees. So this angle here measures 55 degrees. Now let's look at the pink angle here. So my pink angle is going towards the left. So that's exactly where I'm gonna start counting, okay? I'm gonna start counting from the 0. I'm gonna ignore the bigger numbers on the bottom. I'm gonna start counting the numbers from the 0 here to my left. 0, 10, 20, 30, 40, 50, right? And then once I get as close as I can to this ray here, I'm gonna start counting my unit degrees. Here you go. 51, 52, 53, 54, 55 degrees on this side as well. Okay? So each angle here measures 55 degrees. Okay? So we're gonna try it now. Let's have Michaela pass these around. All right, those are protractors. You're gonna pass the protractors. I'm gonna give you an angle, right? Or I'm gonna give you a degree, and you're gonna draw an angle to that degree. Okay. Now, before we go any further, what type of angle is this?
An acute angle.
This is an acute angle. So if it's an acute angle, how many degrees am I expecting? Am I expecting more than 90 or less than 90?
Less than 90.
Less than 90. Now, quick question. What if a wider opening, let's say I had this angle, I'm gonna line it up. I'm gonna line it up to this vertex here. Now I have this angle here. Okay, by the look of this angle, I already know that this angle is a certain type of angle that I'm looking for. What degree am I looking for? Is it greater than 90 or less than 90?
Greater.
Greater than 90, right? So just by you looking at the angles, it could give you or a good idea of what type of angle you're looking at and what numbers you're gonna end up looking at. Let's do this obtuse angle real quick before we go into measuring, okay? Right now, I put my angle along my protractor, okay? I know that my baseline is pointing towards the right. So I'm gonna start counting from the right.
And we start with the big numbers.
No, we don't start with the big numbers. We start with the small numbers. Remember, this is where this ray here is telling you on what side of the protractor am I going to start counting. Am I going to start counting on my right or on my left? Right now it's telling me I'm going to start counting on my right. So let's count from the 0. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. I don't want to pass my ray, okay? So I'm going to stop at 110 and then start counting the unit degrees. 111, 112, 113, 114, 115, 116, 117, 118 degrees. So this angle measures 118 degrees, okay, from your protractor. Now, another thing. Let's say, Mr. J, I have a 75 degree measurement. What angle am I expecting? I'm expecting an acute angle, right? Something that is not too wide. I have a 130 degree or 135 degree measurement.
Obtuse.
You're looking for an obtuse angle, a wide open angle. Okay? So make sure that the numbers could give you, the measurements could give you a clue of what angle you're about to draw, but also the symbol or the actual angle could give you an idea of what number you're looking for. That's why it's very important to know the definition of an acute angle and an obtuse angle. Again, acute angle is smaller or less than 90 degrees. An obtuse angle is greater than 90 degrees. Okay? So let's do that now. Let's grab all our protractors and we're going to start measuring our angles. Let me see. Good. So you're lining up that vertex. Good. Where's your baseline? Yeah, make sure you draw your baseline. And then when you're drawing your baseline, guys, you could use the straight edge on the protractor. Has a straight edge. A straight edge is this straight part right here, guys. Look, this straight part right here. You could use that to draw straight lines. So if you want to draw, let's say you mark your measurement and you want to connect your measurement with the vertex, you're going to use that straight line. Okay, use that straight edge. Good. Now, are those measurements measuring 100 degrees and 90 degrees and 30 degrees, or you're just drawing them out? You got to make sure that you draw them out. Okay, you're going to put your protractor. Okay, that's your baseline. Fine, you drew your baseline. Now, where would the 30 degree would be?
Oh, right here. Okay,
so mark it. Mark it. There. Okay. Now, what you're going to do is you're going to use your straight edge and make your line. There you go, you see? Okay. That's good. That's good. The third thing I want to go over with you guys today would be area finding the area rectangle. Okay, so first things first, I want to go through what we call the area formula. Area formula. Now I want you guys to think about a formula as being like a mold. Have you guys ever been to, obviously, I mean, you went to a supermarket and you bought a dozen eggs, right?
Yep.
You guys bought a dozen eggs, right?
Yep. Yeah.
Okay, so if you look at the egg carton has kind of like a shape to it, right? So the egg goes into that mold, and there's 12 eggs inside those little holes, right? That's called an egg carton, and they're molded to fit, right? To fit those eggs. An area formula, okay, is a mold where all you have to do is replace the formula with numbers that are given to you. So for example, the area formula is L, right, which is length, right, times, this is a multiplication, times width, this is width, which gives you or equals to your area. So for example, I'm gonna give you a rectangle, okay, with measurements of, let's say, 10 and 12 here, okay, 10 and 12, all right, these are the measurements given to you, all right, this is my length and my width. So I am 12 inches wide and 10 inches long, okay? So these are my length, width, length, width. What I'm supposed to do, right, I'm taking these given measurements, the measurements that are given to me, and I am plugging them in to my formula. So my formula, again, I'm gonna put it to the side here, is length times width would give me my area. So I'm gonna start plugging them in. Give me an L, James. Give me one L, one length.
Oh, so 10.
10, good. Jacob, give me a W.
12.
12. You see, all I'm using is, I'm using this formula as a mold to just plug in. It's telling me what I should multiply, right? I'm multiplying my length times my width. Okay, so what is 10 times 12?
120.
120. Therefore, my area for this rectangle is 120. Okay? Now, you say, Mr. J, what is area? What exactly are you looking for in an area of a rectangle? So when you're finding the measurement of a rectangle, you're finding the area of a rectangle, you're looking for the space inside the rectangle, all the space inside that you have occupied. Okay, the space inside. The perimeter, let's go over the formula first. Perimeter formula. Okay, the perimeter formula is actually pretty simple. It's length plus width plus width will give you your perimeter.
So it's basically just adding it?
So you're pretty much adding all the sides, okay? And the perimeter, let's use the same rectangle here. The perimeter is looking for the space around, okay? The perimeter is just around the rectangle. Oh, let's start plugging in numbers. Nathan, what is 1L? I need 1L here.
So 10.
10 plus
10.
10 plus a W.
Oh, 12.
12 plus
12.
12. Good. So you see how I am using my mold, right? And then I'm just giving them what they're asking me for. So they're asking me for 1L, so I'm going to give you 1L. They're asking me for another L, I'm giving you another L. Another W, a W, a W, a W. See? So all I'm doing is plugging the numbers into my formula. Okay? So what's 10 plus 10 plus
36.
12 plus 12?
30. Or 34.
12 plus 12 plus 10 plus 10. Right? So 2 plus 2 is 4. Right? Then 1, 2, 3, 4 gives you 44. Okay? So your perimeter of this rectangle is 44. Okay? So now I'm gonna give you some measurements, rectangles with measurements on them, and you are going to figure the area and perimeter for both. Another thing that I want you to remember, let's say, if you're looking at a rectangle and it's giving you 6 on this side and 12 on this side, right? If this side is 12, what would be the top side?
12.
12. If this side is 6, what would be this side?
6.
6. Those are characteristics of a rectangle that you should know. Those are traits of a rectangle you should know. A rectangle has 2 equal opposite sides. Okay? So if one side is 6, the other side is 6. Okay? If the width on top is 58, the width on the bottom is 58. The side on the bottom is 58. Okay? So remember, a rectangle has 2 equal opposite sides. 2 equal opposite sides. A square is different. A square has equal sides all around, right? Because all the sides are equal. So if the top is 4, the bottom is 4, the side has to be 4, and the other side has to be 4. Okay? Those are characteristics of a rectangle and square that are gonna help you with finding the area and perimeter of shapes. Okay? Because you're gonna come across, find the area and perimeter of this, guys. You're gonna come across shapes like this. Okay? And you're gonna have to find the area and perimeter to this shape. Okay? They're gonna give you given numbers, the lengths, right? All right? So if you see that this side is 5 and this side is 10, that means that this side is half of that side. And then if that's half,
then that should be half.
this should be half because this whole side equals 10. Therefore, this whole side should be 10 as well. Those are the things that you have to keep in mind. Okay? But figure out area and perimeter. Okay? This is what you're probably going to be doing in 5th grade. Okay? Knowing and classifying shapes should have been learned in 3rd grade. Okay? So do me a favor now.
I already got it.
And get the area and perimeter of both. Okay, so we have the area. Okay, you got that. And what's the perimeter? You got to get the perimeter as well.
Oh.
Okay, here. Okay, good job. So you see how an area is multiplying both sides, right? And a perimeter is finding all the sides and adding them up. And you got, good dog. Let me see what you got here. Good, the same thing here.
Good.
Here, I'm not sure what you got, an area. Oh, because you're multiplying. Okay, you're multiplying. And I see how you did it. Okay, that's good. Try next time, try using a standard algorithm for that one. Okay. All right, so that's pretty much it. We're going to go into just our exit ticket. So just to make sure that, and I have a worksheet that kind of covers everything that we've covered today. And again, we're gonna go over it tomorrow, just using different numbers, using different strategies, going into different activities, right? But it's all angles, measuring angles, and finding the area and perimeter. Okay, guys?